Hi everyone, this is your math guru. In this video, I'm going to show you how to prove the following trigonometric equations. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first part of the question, using the diagram given, we have to prove that h equals x sine alpha sine beta divided by sine in bracket alpha minus beta. Using the same diagram, I'm going to start by labeling all the necessary angles and sides. I'm going to label this angle D1, this is angle D2, we have angle D3 to be beta. Also, I'm going to label angle E1 and E2 such that angle D3 is equal to angle F, which is equal to beta, and the reason being alternate angles. Note that the dotted line as shown is parallel to your CF. So therefore, the angle at F is equal to beta. The other angle to label is our angle E1. Angle E1 is equal to angle D2 and 3 or alpha. So I have angle D2 and 3 and that's equal to alpha. The same reason, alternate angles. Therefore, I'm going to label my E to be alpha. Also, note that angle D2 plus angle D3 is equal to alpha. Therefore, to find angle D2, we have alpha minus angle D3, which is the same as alpha minus beta as shown. So therefore, angle D2 is alpha minus beta. To find line DE, I'm going to use the triangle DEF, which I'm going to draw a rough sketch here. I have, this is angle F, angle E, and angle D. As shown in the diagram, this is our beta. We are looking for DE. We have angle D2 to be alpha minus beta. And also we have line EF to be equals to x. Therefore, using our sine rule, we have side DE, which is the side we are looking for, over the sine of the angle facing DE, that's sine beta, equals side x or EF over the angle facing x, which is sine. I'm going to put that in a bracket, alpha minus beta. Making DE the subject of formula, I'll start by cross multiplying. If I cross multiply, I have DE multiplying sine alpha minus beta is equal to x multiplying sine beta. Therefore, dividing both sides by sine alpha minus beta, we have DE equals x sine beta divided by sine alpha minus beta. Now that we know the value of DE, I'm going to use this triangle DCE to find the value of h. Before I do that, note that the angle at D, the whole angle, is equal to 90 degrees. Therefore, to find D1, as shown in the diagram, angle D1 equals 90 degrees minus my alpha. Putting that back into the equation or in the diagram, I have DC to be h. In our previous calculation, we found DE to be x sine beta divided by sine alpha minus beta. Also, we know CE is not given. Then we can slot in the angle at D to be 90 degrees minus alpha. The angle at E or E1 from the diagram is alpha. Therefore, using our trig ratios, we have sine alpha is opposite over hypotenuse, and our opposite in this case, the line opposite our alpha, is our H or our CD over our DE. That's the hypotenuse. That's the same as our H over DE has been given as x sine beta over sine in bracket alpha minus beta. To tidy it up, we have sine alpha equals H. We have H dividing x sine beta over sine alpha minus beta. Using the fraction rule, if we change the division sign to multiplication, we're going to flip the denominator, which becomes sine alpha minus beta over x sine beta. From here, if we cross multiply, we have x sine beta multiplying sine alpha. Remember, sine alpha here is over 1, so cross multiplying, we have that equals 2h sine alpha minus beta. Therefore, dividing both sides by sine alpha minus beta, we have our h to be equals to x sine beta sine alpha divided by sine alpha minus beta, which is back to what the original question says, to say that, show that h equals x sine alpha sine beta over sine alpha minus beta. Let's look at the second example. In this example, we have the triangle PQR. We have to show that the line PS is equal to h sine in bracket theta minus alpha, all divided by cos alpha. Using the same diagram, I'm going to start by taking out the triangle PQR such that the angle at R is 90 degrees. The angle at Q, the whole angle as shown in the diagram, is theta. PQ has been given as h. Therefore, to find cos of theta, we have cos theta equals to adjacent over hypotenuse, and that will be equal to QR over hypotenuse PQ, that's h. Cross multiply, we have therefore the value of our line QR equals h times cos theta. Using the smaller triangle QRS, I have the angle at Q, because it's a smaller triangle, to be alpha. In the previous calculation, I've been able to show that the line QR equals h cos theta. And also, we know that SR is not given, QS is not given. Therefore, to find line QS, using the trig ratio, cos alpha equals to adjacent over hypotenuse. The adjacent is h cos theta, and the hypotenuse is a QS, which is not given. Therefore, making QS the subject of formula, cross multiply, this is over 1. If you cross multiply, you have QS multiplying cos alpha equals to h cos theta. Therefore, our QS equals h cos theta over cos alpha. Now I'll go ahead to use the other triangle PQS such that if you go back to the diagram, if the whole of the angle at Q is theta and SQR is alpha, Then this angle, as shown, will be the whole of the angle, theta minus alpha. So putting that back into my diagram, I have this angle to be theta minus alpha. We've been given QS to be H cos theta over cos alpha. Also, note that to find the angle at P, if I have a rough sketch of the diagram, as shown, this is my 90 degree, that's the angle at R. I know that Q has been given as theta. To find the angle at P, I have angle at P plus Q plus angle R equals to what? 180 degrees. The reason being the sum of angles in a triangle. Therefore, angle P plus theta plus 90 equals to 180 degrees. Therefore, the angle at P will be 180 degrees minus 90 plus theta. Therefore, angle P equals 90 degrees minus theta. So putting that back into the diagram, I have the angle at P to be 90 minus theta, 90 degrees minus theta. So therefore, this angle is 90 degrees minus theta. Using my sine rule, I have my line PS over the sine of the opposite angle, which is sine theta minus alpha, equals, I have the side H cos theta over cos alpha all over the sine of the angle opposite, that's 90 degrees minus theta. Note that sine 90 degrees minus theta is the same as cos theta. Therefore, rewriting the equation I have here, I have PS divided by sine theta minus alpha equals H cos theta over cos alpha times, I change my division sign to multiplication and I flip my denominator, which is my cos theta.